Alrighty, here's a quick video on two rigid motions, translations and reflections. Let's first start with what is a rigid motion. So rigid motion is something in geometry where we transform an object. And when we do the transformation, angle measure and side length has been preserved, meaning that the figure has remained congruent. So you can see down here that figure CBD and figure GEF has been slid, translated, and then reflected. And when that happens, they would land right on top of each other, meaning the two triangles are congruent. So we would have triangle CBD congruent to triangle GEF, meaning that each of the pieces are congruent. Angle C is congruent to angle G, angle B and angle E, and so on. And then each of our sides would be congruent. CB is congruent to GE, and so on. The big takeaway here is that C corresponds with G, so wherever C and G are kind of replaceable between themselves since they're congruent to each other. All right, so our first rigid motion is a translation. So we like to use what are called coordinate rules, and you can see that coordinate rule there at the top is kind of blank. Here's an example right here where that's happening here. We have translated figure TIR to form T prime, I prime, R prime. So to go from T to T prime, you would go right 6, count over 6 units, and down 5 units. So we would put here plus 6. And then since it's gone down 5, we would say minus 5. Okay? And this is a coordinate rule. Let's actually do a transformation here. So here we have triangle ABC, and we would like to move it left 2 and down 5. So what I'm going to do is I'm going to take each of these points. I'm going to start with A, go left 2 and down 5. 1, 2, 3, 4, 5. Put a point. That's A prime. We're going to take B. We're going to go left 2, 1, 2, and down 5. We'll end up there. That's B prime. And then C, we're going to move that one left 2, and then down 5 would end up right there. So there's C prime. And then we can draw our triangle. Now, the other thing we've been asked to do is write a coordinate rule and fill in some ordered pairs. So our coordinate rule for left 2 would be x minus 2, comma, y, not plus, but minus, because we're headed downhill. Right? We're going down. So y minus 2, negative is always down and left. And then what we're going to do to find our ordered pairs is you can either write down the locations of them from your graph, or you could simply take A and you could subtract 2 and subtract 5. So 3 minus 2 is 1. 1 minus 5 is negative 4. 1 minus 2 is negative 1. 4 minus 5 is negative 4. And then 3 minus 2 is 1. And 4 minus 5 is negative 1. Oop, I made a little error here. I was getting ahead of myself. Happens to all mathematicians. 4 minus 5, Mr. Saffel, is negative 1. All right. Now, let's talk about reflections. We can reflect over any line. The lines we talk about in this class are the x-axis and the y-axis. So, the big thing with reflections, the takeaway is each point is equidistant from the line of reflection. So C and C prime are equidistant. C is 3 units from the line here, and C prime is 3 units below the line. This is our coordinate rule for reflections over the x-axis. XY goes to x, comma, negative y. When we reflect over the x-axis, remember that the x-coordinate is the same, and the y-coordinate takes on the opposite. So think that through. When we reflect over x, x doesn't change, y takes the opposite. So here we go. Let's do this. Same triangle we had before. We're going to reflect over the x-axis. So I'm going to write in my coordinate rule first to remind myself what I'm doing. X, comma, negative y, meaning x stays the same, y takes on the opposite. So we are reflecting over the x-axis. So I'm going to draw a big old line over my x-axis to remind us what axes we're reflecting over. Now, A is 1 unit above, So now it needs to be 1 unit below. C is 4 units above, we come 4 units below. Since this is the second time we've done the same triangle for transparency's sake, we could say prime or double prime, it doesn't really matter. C is down here, C prime, and then B would be right here. Draw our figure. And now we can talk about our ordered pairs. So remember, the x's stay the same, so write your x's down, 3, 1, 3. The y's take on the opposite. So the opposite of 1 is -1, the opposite of 4 is -4, and the opposite of 4 is -4. So we've performed a reflection. All right, now let's go over the y-axis. Everything's the same here, but at different axes. And it's very similar to before. When we reflect over the y-axis, here's our coordinate rule, meaning y stays the same. And x takes on the opposite. Again, B and B prime are 2 units from the line of reflection. C and C prime are 7 units from the line of reflection. Each point is the same distance from the line of reflection. All right, let's go ahead and do a quick over the y-axis this time. So I'm going to make a big old obvious line on our y-axis so we can use that as our line of reflection. Now, our coordinate rule for the transforming over or reflecting over the y-axis is x changes to the opposite, y stays the same. So you can do this one of two ways. You can draw your figure first, or you can do your points. I'm going to do my points first. So y stays the same, so it's 1, 4, 4. X takes the opposite. So -3, -1, -3. Now, if you went and plotted these points on your Cartesian plane, it would all work out and look nice, or you can do it more from a more visual approach. A is 3 units to the right. Now A prime needs to be 3 units to the left. All right, so let's go ahead and draw these points. So A is 3 units to the right. A prime would go 3 units to the left. B prime is 1 unit to the right, so it would go 1 unit to the left. And C prime, 3 units, 3 units. Notice everything about my triangle is exactly the same. The length of A prime C prime is the same length as AC. And there you go. That is reflections and translations.